Welcome. This video explores JavaScript Scope, a fundamental concept for writing clean and organized code. We'll delve into how scope determines variable accessibility and helps structure your projects. We will cover variable visibility and access control. Next, we will look at code organization and structure. Then we will discuss scope hierarchy and chain. Lastly, we will learn best practices and patterns for effective scope management. Let's start with global scope. Variables and functions declared outside of any function or block are considered to have global scope. This means they can be accessed from anywhere within your program. They are accessible everywhere in your code. However, using global variables can lead to naming conflicts and makes it difficult to manage the overall structure of your code. Therefore, it's recommended to avoid using global scope for better code organization. Here's an example. We have declared a variable called global var with the keyword var, and initialized it with the string, I am global. Similarly, we have declared another variable called global let, with keyword let and initialized it with the string, I am also global. And lastly, we have declared a constant named global_const initialized to the string, I am a global constant. Inside the function sum function, all the global variables global var, global let and global_const can be accessed and also modified. Now let's explore function scope. Variables declared inside a function are only accessible within that function. This helps to keep your code organized and avoid naming conflicts. Inside the outer function, a variable called message is declared using the let keyword. This variable is only accessible within the outer function. Similarly, a function inner function is declared which has a variable reply declared using let keyword. The inner function can access the variable message declared in the scope of outer function. However, if we try to access the variable reply outside the inner function, it will result in an error. This is because the scope of reply is limited to inner function. The inner function can be invoked inside the outer function. This is demonstrated visually in the diagram. Let's dive deeper into function scope. Each function creates its own isolated scope, preventing variable name conflicts. In this example, we see two variables with the same name counter. One is a global variable, initialized to 0, and the other is declared inside the function increment, initialized to 1. When increment function is invoked, the local variable counter is used. And it does not affect the global counter variable. Also, function parameters are scoped to the function just like local variables. In the greet function, name and message are only accessible within the greet function's scope. If you try to access these variables outside the greet function, you will encounter an error because they are undefined outside this function. Additionally, local variables shadow outer scope variables with the same name. This means that if a variable with the same name exists in both the local and outer scope, the local variable takes precedence within the function's scope. These advanced concepts help us manage the scope of functions better. Next, let's discuss block scope. Variables declared with let and const keywords inside a block, such as an if statement or a loop, are only accessible within that block. In the provided code example, if a variable is declared with let or const inside a block, it cannot be accessed outside the block. But if a variable is declared with var keyword, it can be accessed outside the block because the scope of var is limited to the function. The variables declared with let and const are block scoped and not hoisted, whereas variables declared using the keyword var are function scoped and hoisted. Block scope applies to if statements, loops, switch cases, and standalone blocks. A visual diagram is provided to give a better understanding. The red arrow illustrates that var escapes the block. The green arrow illustrates that let and const stay within the block. Now let's explore module scope. In modern JavaScript, ES6 modules provide a way to encapsulate code and manage scope effectively. Each module has its own scope, keeping variables and functions private by default unless explicitly exported. This encapsulation helps in preventing naming conflicts and manage state within each module. The code shown here demonstrates that a variable counter is private to the mathutils module and can be only accessed inside it. The add and get count functions can be exported and used in another module like app.js. In app.js, the counter variable cannot be accessed directly. Only add and get count can be accessed, and these maintain their own scope from mathutils.js. Modules are singletons. The same module imported in multiple places shares the same state. You can use named exports for multiple values, or default export for a single main value from a module. Let's delve into closure scope. A closure is formed when a function is defined inside another function, creating a scope that maintains access to variables in its outer scope, preserves data privacy, and creates a persistent scope after the outer function returns. The example given here shows that the function createCounter returns an object that has three functions: increment, decrement, and getCount. The variables declared inside the createCounter function are not directly accessible outside it. The scope is maintained, even if the outer function has returned. Each closure has its own independent scope, making it perfect for creating private state. A diagram shows how closure works. The variables and the functions are encapsulated within the closure. The arrow represents the access of the functions inside closure to the variables of the closure. Let's see some practical applications of closures. Closures are used in various JavaScript design patterns. One of them is memoization. Memoization involves storing the results of expensive function calls to avoid redundant calculations. Here, the memoize function returns a new function that caches function results. Closures are also used for partial application. Partial application lets you create new functions by pre-filling some arguments of an existing function. The partial function takes the function and the arguments and returns a new function with those arguments pre-filled. This makes the new function simpler and easier to use. Closures are used for data privacy by creating private variables and methods. It helps in creating function factories by creating specialized functions using partial application and currying. And lastly, closures are used for state management, to maintain persistent state between function calls without relying on global variables. Closures are a fundamental part of JavaScript design patterns and functional programming. Now let's understand the scope chain and variable lookup. JavaScript searches for variables in a specific order, following the scope chain. In this example, we see that a variable called global is declared outside any function. Then a function called outer is declared, that has a variable outervar declared inside of it. Inside the function outer, another function called inner is declared that has innervar declared inside of it. When inner function is invoked, it first searches in its local scope and finds innervar. Then it looks in outer scope and finds outervar. Then it moves up to the global scope and finds global. If it can't find a variable in any of these scopes, it throws a reference error. JavaScript follows a sequence in looking up for variables. First, it checks in the local scope. Then it goes up to the outer function scope and finally it checks the global scope. This order is visualized in the diagram. Finally, let's explore some best practices for managing scope in JavaScript. Always use strict mode to prevent accidental global variable creation. Use of strict mode also prevents any accidental errors. Always keep the variables in the smallest possible scope to reduce the naming conflicts. For better scoping control and clearer code, always prefer let and const over var. Lastly, use ES6 modules to organize code and control the visibility of functions and variables. Let's see some examples. In the bad practice code, variables are accidentally created in the global scope, which should be avoided. Always create the variables in a local scope, using let or const. In the second example, we see how we can use modules to organize the code and control the visibility using the export keyword. By implementing these practices, you can make your code cleaner and easier to maintain. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.